Hello everybody, my name is Phước and I come from Group 4. Today I would like to tell you about the solution of the assignment 1 from the major petroleum production technology. First, let's have a quick look at the problem 1 here. We have the production rate is about 80 steady barrel per day, and the range area is for the 640 arcades. Use the well and the reservoir properties in the table here. We will calculate the total pressure gradient for value of skin from 0, 5, 10, and 20. Then we will plot the graph pressure drawn down versus the skin. So for the given data, I will make a table like this from here. You can see for the information I will set the color is blue, and for the number is orange, and for the parameters here I will use green. First, let's talk about equation. The equation to determine the relationship between the pressure drawdown and the constant flow rate is this one. So we will replace the numbers uh, for these parameters here. Then we will have this number uh, for this one. After we multiply and divide the numbers, we will have this number here, and we take the logarithm of this number. Uh, don't care about the scale factor here. We will have 9.1141 here is like this, the one here I calculated here. So then we will multiply the 48 to 9 here, and we will have the numbers for 442.9. We will plus with this number and the skin factor here. So from now we will have the delta B is stand for the pressure drop, or we can say the total pressure gradient here. So we will replacing the skin factor for 0, 5, 10, and finally is 20 here, and we will have the pressure loss is equal to 0 over 200 over 400 and nearly 1000 here. And for the total pressure gradient, we will use this number to plus with these four number here. Then we will have the numbers here. For calculate the fraction of the pressure gradient, we will use the pressure loss. Then we will divide to the total pressure gradient, and we will have these numbers. And move to the graph here. It shows us the pressure drawdown versus the skin factor when the skin factor is arranged from 0 to 20, for the pressure drawdown is arranged from 0 to 0.8. And you can see that this graph has increasing trend line here. Okay, I think it's enough for the problem 1 because it's kind of easy. So move to the problem 2. It's quite similar to the problem 1 here. So we will have the same table data, and which form is the the requirement want us to calculate the average reservoir of the second, calculate the average pressure of the second reservoir. So we will use the same formula from the problem 1 here, but in this case we must calculate the two wells for the two formulas here. This okay. Then we will replace the numbers to calculate the logarithm of it. For this one here is either radius of the well one, and this one is the radius of well two. For the skin factor in this case is equal to zero, so we can cancel out it. uh, After divide these two equations, and we have this number 1.04. It also be the ratio of the two pressure here, and we we continue replacing this number here for the average pressure of well one is about, let me see, is about 6,000 here, and for the bottom hole flowing pressure is 3,000 here, and we want to calculate the average pressure at the second reservoir. So we will replace this one to the equation, and we will have the average pressure at the second reservoir is about 5,000 5,875.68 psi. Okay, continue to the problem tree here. So the same for both problems before. Uh, I will have the same. I will have the same data table here, and for the requirements of the problem, first we will calculate the BT, NI, and NT here. For the BT here, we will use the B0 to plus with constant. After calculate this one, after a long calculation, we will have this number here. The same for NI and NT here, and for the formula over here, is the formula to calculate the flow rate. And for the uh, pressure, the bottom hole flowing pressure, yes, for the bottom hole flowing pressure, it will change from 0 to the 4,000 and 4,350 feet. Okay, 4 feet. And for the flow rate here, we use this formula to calculate it, replacing the numbers over here to this formula. We will have the flow rate, the suitable flow rate for each pressure. Okay, here, and to plot the graph, we will use these two what should I say, these two parameters here. First for the bottom hole flowing pressure, and the second is for the flow rate. It's also called the IPR. We can see that it begin from this point, and its end at this point is about is over 1,400 a little bit here. Okay, do these curves in a single figures, do the approach to each other small x. Yes. Okay, I think it's also enough for the problem 3. Continue to the problem 4 here. For the problem 4, the requirement is we will calculate the relative contribution to the flow rate from the pressure differences above and one below the purple point, which means we will calculate in two cases. First for the above the purple point, and the second is the below the purple point. the same the same like others problem. We also have the data table here, and in this case the scale factor also be 0, also equal 0. So first we will calculate QB by this equation. uh, After replacing these parameter, we will have this number, and for the J here, it's the same. QB Q0 is still the same. Okay, let's show you for C15 and F12. C15 and F12. F12 is here. Okay, C15, 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 C15. Okay, okay. We use this number and multiply by b, then we divide for 1.8. And for the q0 here, we will use both qb here and qv here already calculated, and um, um, the bottom hole flow pressure bb. uh, this one also shown use for in the data table, so you can use it. And for the relative contribution of the flow rate, this one QB over Q0 is for the over the purple point. Uh, you can see this is the percent for the 0 point is nearly 0.53, and for the below the purple point is 0.47. If you take a sum of it, it will be 100%. Okay, to the problem 5. um, the problem 5 also wants us to plot the IBR curve, so we must have the bottom hole pressure, bottom hole flowing pressure, and the flow rate. So we use the the given data from the table here and applied the Vogel methods. Oh, okay. First, let's talk about this because because in this case the bottom hole flowing pressure is larger or equal than the PB. So we will use the Vogel method. We first will calculate the J by these numbers. We will calculate that the J is equal to 0.5, and for the QB here, we will use J multiply for the pressure of the PR, the PR bar, and the PB. For this number is 435. Then we will use these two numbers to calculate the flow rate, and for the difference and for the different pressure, we will have a different flow rate. Then we will use these two parameters to plot the IBR curve. Here you can see this is the IBR curve for the problem 5, and move to problem 6 here. Okay, the problem 6 is quite long. So first, this have the two requirements for us. For the A, the problem requires us to construct a complete IBR using the Pekovic method, and for the second one, it's also the IPR, but when the pressure declines to 2,500 psi. So for the given data here, first we will have the given data here, then we will calculate the average pressure, for 4,000 for I'm sorry, the it's also given the pressure, the average pressure is for 4,320 psi here, and we will take the graph for the flow rate uh, and this one here. Okay, you get this one, and for calculate and for A and B we will choose from A B we choose 2 points from this graph, choose randomly from this graph. I'll choose for 160 right here for this for the graph here, because it's a right on the trend line here. Okay, this one is okay. This one is what we choose, and this one is what we calculate. What is what we calculated. Um, and for n, we will take the logarithm of. Let me see. Of okay, of the point B over point A. Okay, we divide by the we divide it by the logarithm of these two number, and for the C, we will use okay, we will use the flow rate. We will divide for the number from here. Okay, um, let's see. Let's talk for some. After calculating, we will have C. Okay, for the Vogel method, it's the same for the problem 5 before. So we have the equation to calculate the Q0 in the max case, like here, and for the Q0, and we will calculate the Q0 here. And oh, sorry, this is for the Vogel, but this one is for the Vekovich method. Is what the A requirements want us to do. For the flow rate of Vekovic method, we will calculate by this equation. Then we will have this number for each of the pressure here. Then we will use these two parameters to plot this IPR for A, or you can see, or you can call this the IPR for the Vekovic method. And move to B. We will decrease the pressure down to 2,500 psi. So it will begin from 2,000 and see. It will begin from the 2,500 here, and yes, for the same calculation like the A1. Okay, to the problem 7. So the problem 7, we must calculate the 7 things by using this by using these given data here. So first for the molecular weight, we will calculate based on this table, the table here. Okay, let's move to the first one, the pseudo-critical pressure, PPC here. For the PPC, you can calculate by using the table over here. And for the TBC, it will have the equation here to calculate the TBC for the pseudo-critical temperature, and for the pseudo-receive pseudo reduced pressures, PPRI and PPRI and PPRA. Okay, C14. Uh, for the pseudo reduced pressure PPRI, you will take the initial pressure, then we will divide for the pseudo critical pressure PPC here. Then we will have the first one is the PPRI, and for the PPRI, you will use the PI here. PI, then you divide for the pseudo critical pressure the same here. Then you will have this number. Next, for the fourth one is pseudo reduced temperature TBR here. TBR, we will use the temperature, then we will divide by let me see, 372. Then we will get the TBR. The fifth one is the deviation factors ZI and ZA. Okay, for ZA, you can use the pseudo reduced pressure to choose the compressibility factor Z by using the table here. For the BGI here, is the gas volume factors for the BG. This equation is here. Okay, you can use this equation to calculate both BGI and BGI here by let me see, for the BGI we will use the ZI, and for the BGI we will use the ZI. The temperature is the same, so we keep the temperature for both two case is equal. Next is GI and GA. This is about the initial gas in place and the gas in place at abandonment GA. Okay, GI and GA, you can use this equation to calculate GI and GA. And finally, is for the recovery factor of the well. For the recovery factor of the well, you can calculate by use you can use 1 minus for the BGI, the gas volume factor BGI, then divided by the BGA. You have the recovery factor is about over 80%. And for the final problem 8, we will have a lot of not so much given data here. So the requirements of it is wanted to plot both IPR and VLP in the same graph. Okay, let's start with A and B. Okay, let's talk about the equation here first. For week Q0 is the flow rate. Okay, for and you can calculate AB by this equation, and then we will have AB here. And first is for the IPR. For IPR, we must calculate like the problems before. First, we will calculate the pressure, the bottom hole flowing pressure. for the PDF here and for the flow rate here, use the equation here. Okay, for the pressure, we will arrange from 0 to 4,513 feet. And for the flow rate, okay, you can have this number and move to S here is about the skin factor. We will use for this we will have the sin pi over 2 for the skin factor here. So sorry. For the VLP, we will calculate the random number from this equation, especially this one is taken by the fluid mechanics course. So let's have a look of it. We will calculate the random numbers for each. Let me see. For each parameters here, about the FF here. Okay, you see the FF here, and the especially in this case, the where is it? Okay, the well deliverability. Okay, the flowing wellhead pressure is 500. So for the BTF here is equal to each other is 500, and for the pressure, the bottom hole pressure, it will be okay. It will be calculated by this equation, and for oops, sorry. Okay, uh, we will calculate for okay, we'll calculate the uh, bottom hole pressure here. Then we will plot the relationship between the IPR and the VLP curve here. We will use for the IPR, you already know that we will plot by the bottom hole pressure and the flow rate here. And for the VLP, we will use the flow rate of the IPR and the bottom hole pressure for the VLP to plot it. Okay. Thanks for listening to me to the end of this video, and goodbye.